General relativity. Topics: Principle of equivalence, bending of light by gravity. Gravity in time, gravitational redshift. Gravity in space, motion of Mercury. Gravity, space, and a new geometry. Gravitational waves. PBS relativity animations. http://www.pbs.org/wgbh/nova/einstein/relativity/ Special relativity length contraction. Equivalence principle. Curved space. Equivalence principle. Observations made in an accelerated reference frame are indistinguishable from observations made in a Newtonian gravitational field. Acceleration and gravity equivalence. To an observer inside the accelerating ship, a lead ball and a wood ball appear to fall together when released. Trajectories: if the ship is accelerating, the floor overtakes the ball. An observer outside the ship sees a straight line path. An observer in the accelerating ship sees the path as curved, it is a parabola. Acceleration deflects light. An outside observer sees light travel horizontally in a straight line, but it strikes the wall slightly below a point opposite the window. B. To an inside observer, the light bends as if responding to a gravitational field. Gravity bends light. According to the principle of equivalence, if light is deflected by acceleration, it must be deflected by gravity. How can gravity bend light? According to Newton's physics, gravitation is an interaction between masses. A moving ball curves because of the interaction between its mass and the mass of the Earth. But what of light, which is pure energy and is massless? Energy of light. Einstein's answer was that light may be massless, but it's not energy-less. Gravity pulls on the energy of light because energy is equivalent to mass. Later Einstein added the idea of curved space-time. Light from star bent by sun. Einstein's calculations indicated that the light from a star which just grazed the sun should be deflected by 1.75 seconds of arc. It was tested during the total eclipse of 1919 and during most of those which have occurred since. Bending of light? Why do we not notice the bending of light in our everyday environment? Check yourself. Why do we not notice the bending of light in our everyday environment? Only because light travels so fast. Just as over a short distance we do not notice the curved path of a high-speed bullet, we do not notice the curving of a light beam. Gravity in time. According to Einstein's general theory of relativity, gravitation causes time to slow down. Time. Clocks 1 and 2 are in an accelerating disk, and clock 3 is at rest in an inertial frame. Clocks 1 and 3 run at the same rate, while clock 2 runs slower. From the point of view of an observer at clock 3, clock 2 runs slow because it is moving. From the points of view of an observer at clock 1, clock 2 runs slow because it is in a stronger centrifugal force field. Clock 1 is rotating but has no linear speed WRT. Clock 3. Clock runs slower at Earth's surface. By applying the principle of equivalence, which says that any effect of acceleration can be duplicated by gravity, we must conclude that as we move in the direction that a gravitational force acts, time will also be slowed. Gravitational redshift. All atoms emit light at specific frequencies characteristic of the vibrational rate of electrons within the atom. Every atom is therefore a clock, and a slowing down of atomic vibration indicates the slowing down of such clocks. An atom on the Sun should emit light at a lower frequency, slower vibration, than light emitted by the same element on the Earth. Since red light is at the low frequency end of the visible spectrum, a lowering of frequency shifts the color toward the red. Mossbauer effect used in 1960, an entirely new technique. Using gamma rays from radioactive atoms. Incredibly precise and confirming measurements of the gravitational slowing of time between the top and bottom floors of a laboratory building at Harvard University, precession of Mercury. Near the Sun, where the effect of gravity on time is the greatest, the rate of precession should be the greatest. The orbit of Mercury does precess, above and beyond effects attributable to the other planets, new geometry. When the disk is not rotating, CD equals pi. When the disk is rotating, CD does not equal pi. And Euclidean geometry is no longer valid. Measuring stick along the edge of the rotating disk appears contracted. Measuring stick farther and moving more slowly is not contracted as much. Measuring stick along a radius is not contracted at all. Sum of triangle angles. The sum of the angles of a triangle depends on which kind of surface the triangle is drawn on. A. On a flat surface the sum is 180 degrees. B. On a spherical surface the sum is greater than 180 degrees. C. On a saddle-shaped surface the sum is less than 180 degrees. Geodesics. The light rays joining the three planets form a triangle. Since light passing near the sun bends, the sum of the angles of the resulting triangle is greater than 180 degrees. These lines of shortest distance are called geodesic lines or simply geodesics. The path of a light beam follows a geodesic, curved universe. The whole universe may have an overall curvature. If negatively curved, it is open-ended like the saddle and extends without limit. If positively curved, it closes in on itself. One familiar example of a positively curved space is the surface of the Earth. Einstein's universe. Space tells matter how to move, and matter tells space how to curve. That's it.